Study attitude with the scientific method, a self-correcting process for evaluating ideas with observation and analysis. In this attempt to describe sounding theories and put them to the test, if a theory works, if the data supports it, predictions, so much the better for that theory. If the prediction fails, the theory will be reversed or rejected. Chatting with friends and family. We often use the theory to mean mere hunch. In science, a theory explains behaviors or events by offering ideas that organize what we have observed by organizing isolated facts. A theory simplifies. By linking facts with deeper principles, a theory offers a useful summary. As we connect the observed dots, and coherent pictures emerge. A theory about effects of sleep on memory, for example, help us organize countless sleep-related observations into a short list of principles. Imagine that we observe over and over that people with good sleep habits tend to answer questions correctly in class, and they do well at test time. We might therefore theorize that sleep improves memory. So far, so good. Our principle neatly summarizes it as a list of facts about effect of the good night's sleep on memory. Yet no matter how reasonable a theory may sound, it does seem reasonable to suggest sleep could improve memory. We must put it to the test. A good theory produces testable predictions, like hypotheses. Such predictions specify which results would support the theory, what results would cast doubt on the theory. To test our theory, the effects on sleep on memory, our hypothesis might be when sleep-deprived people will remember less from the day before. To test the hypothesis, we might assess how well people remember course material they studied before a good night's sleep, or they should be taking shortened night's sleep. The results will either confirm our theory or lead us to revise or reject it. Our theories can be biased on our observations, having theorized that better memory springs from more sleep. We may see what we expect. We may perceive sleepy people's comments as less insightful. Perhaps you are aware of students who, because they have developed an excellent reputation and can now do no wrongs in the eyes of the teacher. If they're in the hall during class, nobody worries. Other students can do no good because they have behaved badly in the past, or even their positive behaviors are viewed suspiciously. As a check on their bias, psychologists use operated definitions when they are reported their students sleep deprived. For example, they may be defined as X hours less than the person's natural sleep. Unlike dictionary definitions, operational definitions describe concepts with precise procedures or measures. These exact descriptions will allow anyone to replicate the research. Other people can recreate the study with different participants in different situations. If they get similar results, we can be confident that the findings are reliable. Let's summarize a good theory. Effectively organizes a range of self-reports and observations, leads to clear hypothesis predictions that anyone can use to check on the theory, often stimulates research that leads to revised theory which better organizes and predicts what we know. Or our research may be replicated and supported by similar findings. We can test our hypothesis and refine our theories in several ways. Descriptive methods describe behaviors often by using case studies, surveys, or naturalistic behaviors. Correlation methods associate different factors or variables. Experimental methods manipulate variables to discover their effects. To think critically about popular psychology claims we need to understand the strengths and weaknesses of these methods. Psychologists use this case study, which is the oldest research method, to examine one individual or group in depth, of hoping to reveal things true of all of us. Some examples Much of our early knowledge about the brain came from case studies of individuals who suffered a particular impairment after damage to a certain brain region. Jean Piaget taught us about children thinking through case studies, and he carefully observed and questioned individual children. Studies of only few chimpanzees have revealed their capacity for understanding and language. Intensive case studies are sometimes very revealing. They show us what can happen and often suggest directions for further study. But individual cases may mislead us if the individual is atypical. Unrepresentative information can lead mistaken judgment and false conclusions. Indeed, anytime a researcher mentions the findings, someone is sure to offer contradictory antidote. Dramatic stories and personal experiences command our attention and are easily remembered. Journalists understand that, and so being an article about blank foreclosures with the sad story of one family put out their house. Not with foreclosed statistics stories moved us, but stories can mislead. Which following do you find more memorable? In one study of 1,300 dream reports concerning a kidnapped child, only 5% correctly envisioned the child as dead. I know a man who dreamed his sister was in a car accident, and 2 days later she died in a head-on collision. Numbers can be numbing, and the plural of antidote is not evidence. As psychologist Gordon Allport said, given the thimble of dramatic facts, we make rush to generalizations as large as a tub. The point to remember, individual cases can suggest fruitful ideas. What's true of all of us can be a glimpse in any one of us, but discern general truths that cover individual cases. We must answer questions within research methods. Naturalistic observation. A second descriptive method records behavior in naturalistic environments. These naturalistic observations range from watching chimpanzees societies in the jungle to obtrusively videotaping parent-child interactions in different cultures to recording racial differences in students' self-seating patterns in school cafeteria. Like the case study, naturalist observation does not explain behavior. It describes it. Nevertheless, descriptions can be revealing. Once thought, for example, that only humans use tools. The naturalistic observation revealed that chimpanzees sometimes insert a stick in its termite mound and withdraw it, eating the stick load of termites. Such obtrusive naturalistic observations paved the way for later studies of the animal thinking, language, and emotion, which further expanded our understanding for our fellow animals. Observations made in the natural habitat to help show that society's behaviors of animals are far more complex than previously supposed. Chimpanzee observer Jane Goodall noted, thanks to research observations, we know that chimpanzees and baboons use deception. Psychologists Andrew Whitten and Richard Bryan repeatedly saw one young bamboo pretending to have been attacked by another as a tactic to get its mother to drive the other bamboo away from its food. The more developed a primate species brain, the more likely it is the animal will display deceptive behaviors. Naturalistic also illuminate behavior. Here are 4 findings you might enjoy. A funny finding: we humans laugh 30 times more often in social situations than solitary situations. As we laugh, 17 muscles contort our mouth and squeeze our eyes, and we emanate a series of 75 millisecond vowel-like sounds, spaced about 1/5 of a second apart. Sounding out students. What really are college psychology students saying and doing during their everyday lives. To find out, researchers equipped 52 such students from the University of Texas with electronic recorders for up to 4 days. A recording captured 30 seconds of the students walking every 12.5 minutes, thus enabling the researchers to eavesdrop more than 10,000 half-minute life slices. By the end of the study, on what percentage of the slices do you suppose they found the students were talking with someone? What percentage captured the students at a computer? The answer, 28 and 9%. What's on your mind?